Okay, 1.2 Applications of linear equations and rational equation. In section 1.1, we discuss about how to solve linear equation in one variable and at the same time rational equation in one variable. In this section, we're going to solve some application problem. Application problem means always you see, word problem. It's taking from the real life situation, and then we try to convert them into a linear equation or rational equation, and we try to solve those equations for finding the solution of real life problem. And these are our objective. We change the word problem into mathematical problem. uh, you know Most of the time we need to find out something unknown. For that unknown we introduce a variable like x. Okay, sometime we might have to use geometric structure to find out the relation, and sometime it might be mixture problem. Okay, so there are different areas we can pick the problem, and then we can use technique of solving linear equation and rational equation. Okay, so that's what we're going to see. I'm going to take a couple of example in this section, but before that we have to make sure that you understand the meaning of word we are using. So addition, which is plus sign, also can be we also have to understand the meaning of addition. Sometimes we might use sum or more than or total, these words, to represent addition. Difference, less than, minus, to represent subtraction. Multiplication can also be used for product, and then times. Division means quotient, that is also division. Divide by, that is also division. Per, if we use these words, that stands for division. Sometimes whenever we see is, that means it's an equation, equal sign. So whenever we try to solve word problem, and when we convert that word problem into mathematical equation, we need to think about these words. Okay, let's try this example. The first one, we need to rewrite this statement using algebraic expression or equation. So the first one, 7 more than 3 times a number. In this statement, we don't know what is a number. So whenever we don't know about, if there is an unknown thing, we always introduce variable for that. So for our example, let's use x as a variable. So we don't know x, but we have given some statement about x. 7 more than, so 7 more than 3 times x. 7 more than, so remember, if you go back here, more than we can use for addition. So 7 more than 3 times a number, which is 3 times x. So this expression, this statement also can be written as 7 plus 3 times x. So this expression says 7 more than 3 times a number which we don't know, unknown number. Okay, so that's how we have to change the expression into algebraic statement into algebraic expression. So this one, 5 less than twice a number. So again, a number is x, twice a number is 2 times x, and our expression is it's a 5 less than 2 times x. So we have to subtract 5 from 2 times x, because our statement says our expression should be 5 less than 2 times x. Okay, so it should be 2x minus 5. See, 3 times the quotient of the number, of a number. So one more time, number is x, and quotient of number and 11 is x over 11, and 3 times that expression is 3 times this one. So 3 times quotient of a number, which is x, unknown number, and 11. D, the sum, so that means addition of a number. So we don't know about this number, so let's use x. The sum of x and 9, so x plus 9, is 1 less than, so 1 less than what? Half of the number, the very same number x. So sum of x plus 9 is, so look at here, is means equal to 1 less than, we need to subtract 1 from half of the number, from half of the very same number. So this is, this statement is actually an equation. Sum of x and 9 is meaning equal to 1 less than half of the number. Okay, the product of a number, one more time, number means x, the product of x and 4, which is 4 times x, is 1 more than, is means equal to 1 more than, that means 1 plus 8 times the difference of 10 and number. So 10 comes first and number comes after that. So you have to find the difference between 10 and x. So the product of, product means times, number x and 4 is equal to 1 times more, sorry, 1 more meaning 1 plus 8 times the difference of 10, so 10 comes first, and the number which is x. So this is the step. Okay, so that's how we need to change the statement uh, into algebraic expression. So whenever we try to solve problem, word problem, especially using this linear equation and then rational equation solving technique, first of all we have to read the problem very carefully, and then we have to introduce variables. What is unknown? For those unknown, we have to introduce variable. So in our case, in this section, one variable is enough. So you have to introduce one variable like x or y or z or w, whatever. So to convert the problem to convert the word problem into mathematical expression, read the problem very carefully, introduce the variable for unknown thing, and then convert that word problem into mathematical expression. So step 1, read the problem several times until you have an understanding of what is being asked. So until you understand what is you are trying to find, you are not going to solve it. So you have to read the problem. You have to pick a variable that describes the unknown quantity that is to be found. All other quantities must be written in terms of that variable. Write an equation using the given information and the variable. Carefully solve the equation. And after solving the equation, make sure that you have answered the question and then check all the answer to make sure they make sense. So basically you have to read the problem, introduce variables, change that statement into mathematical expression, solve that a mathematical equation, and come back and give your finding. I'm going to do a couple of examples in this section. So let's start with this one. Together, Steve and Tom sold 112 raffle tickets for their school. Steve sold 16 more than 3 times as many raffle tickets as Tom. How many raffle tickets did each boy sell? Okay, so here we need to find out how many raffle tickets Steve and Tom sold. So for that we can say, okay, the number of raffle tickets sold by Steve, Steve sold, let's say Steve sold X many, X number, that's just a number. Now we can express you know Tom raffle number in terms of X by using the relation we have given. So just go back and read this problem one more time. Together Steve and Tom, they sold 112 raffle tickets. Steve sold 16 more than 3 times as many raffle tickets as Tom. Okay, so Steve sold, okay, so I have to just interchange this variable. So I'm going to it would be easier. I'm going to say, let's say Tom sold X many. Then now I can find out Steve, because here Steve sold, we have given one expression, one statement. Steve sold 16 more than 3 times as many raffle ticket as Tom. 16 more means 16 plus 3 times the 3 times ticket Tom sold. So we know that Tom sold X many. So Steve sold 16 plus 3 times X. Because as you can focus here, Steve sold 16 more means plus, than 3 times the number of ticket Tom sold. And we know the Tom sold X many. Okay, so that's why we can say let Tom sold X many. So we have to go from here. Then so my first of all I had to write this thing first. Okay, then Steve sold 16 plus 3x. But altogether if you add you know uh, the raffle tickets, the number of raffle tickets Tom sold and the number of raffle tickets Steve sold, the sum should be 116. That's sorry, 112. That is given here. So we can say 16 plus 3x plus x equal 112, because together Steve and Tom they sold 112. Okay, so now we need to just solve this linear equation. 16 plus 4x equal 112. So just subtract 16. So it's gone. 4x equal 96. And if you divide both sides by 4, x equal 24. So this x is actually number of tickets Tom sold. So we can go back to the problem and we say Tom sold 24 raffle ticket. And now we know, because Steve sold 16 plus 3 times 24. So and Steve sold, just find out that 16 plus 3 times 24. 24 times 3 is 72 plus 16 is 88. So 88 plus 24 is actually 112. So these are the answer. Tom sold 24 tickets and Steve sold 88 tickets. So the tricky part is introducing the variable, the x, to the right person, and then finding the value of another, like for the Steve, using the relation you have given in the problem. Let's see another example. The perimeter of a rectangular garden is 144 meters. So first of all, if you can, always draw a picture. So there is a rectangular garden. So perimeter means the length of this side plus this side plus this side plus this side. So one side is L, the another side is W, length, width. So if you add all these four sides, that is called perimeter. And we have given that is 14 meters. So now the second thing is the length is 6 meters longer than twice the width. So for example, let's say the width is W, which is this one. Then according to this problem, length is 6 meters longer. So that means 6 plus twice the width. 6 plus 2 times width. And remember, this length and width, they are measured in meter. So now we know the width is W, then length is 6 plus 2 times W. So we know for the rectangle, the opposite side should be equal. So this side should be W and this side should be 6 plus 2 times W. Now because the rectangular garden has 114 meter perimeter, so after adding all these four, which is basically W plus 6 plus 2 times W plus 6 plus 2 times W equal 114. So I'm just adding opposite sides. So now for finding the value of width, just do the simplification. 1W, W, 2W, 2W, 2 plus 2 plus 1 plus 1 is 6W, plus 6 plus 6 is 12, equal 114. Our goal is to solve for W, so just subtract 12. So 6W equal 100 and what is that? 2. Now just divide both sides by 6. So if you divide both sides by 6, uh, 6 1 and then 6 7, so width is 17 meter. Good. So now for finding the length, since we know the length is 6 plus 2 times width, so length is 6 plus 2 times 17, which is 34 plus 6 is 40 meter. Okay, so width is 17, 17, 17, this side is 40 and this side is 40. So 40 plus 40 is 80, 17 plus 17 is 34, 80 plus 34 is 114. That's the perimeter. So for this problem, the width of the garden is 17 meter and length of the garden is 40 meter. Let's go to the last problem for this section. A triangular shaped deck has one side that is 4 feet longer than the shorter side. So there is a triangular shaped deck. Okay, so here one side that is 4 feet longer than the shortest side. So for example, let's say this is the shortest side and the length of this side is x. So one side is uh, 4 feet longer than this shortest one. The another side is 4 feet shorter than twice the length of the shortest side. So it's a 4 feet shorter. So that means you have to subtract 4 from 2 times x. So look at here, read it. Third side that is 4 feet shorter, meaning you have to subtract 4, then twice the length of the shortest side. So these are the value for these three sides. X is the shortest one, another one is 4 feet longer than the shortest one, so that's 4 plus x. Another one is 4 feet shorter than twice times shortest one, that's why it's a 2 times x minus 4. Okay, all together the perimeter means if you add all these three sides, that would be 52 feet. So just add them. 2x minus 4 plus 4 plus x plus x. So this is this one. 4 plus x is this one and x is the third one, equal 52. So now just solve for x. 2x plus x is 4x. This 4, negative 4 and positive 4 is gone. So if you solve for x, just divide both sides by 4. So you find that x is 13. So that means the shortest length is 13 feet. So another one would be 4 plus 13, which is 17 feet. And another one is 2 times 13 minus 4, which is 26 minus 4, which is 26 minus 4 is 22 feet. So if you add 13 plus 22 plus 17, which is 52, that's the perimeter. Okay, that's how we can solve application problem where we need to use linear equation or rational equation.